Test. All right, there we go. Boom. Where are we at? We're right there. Okay. The first part I'm really good at. The second part I'm not so good at. So, hey, AP calculus is not that easy. Okay, it's easy for you guys, but it's not so easy for me. I'm kidding. No, it's just remembering the formula for inverse functions. I wonder if you have your formula. I don't know if your formulas for inverse functions are on your formula sheet or not.
So you're gonna try inverse trigonometry. You can't memorize.
Yeah.
No.
I don't even know. No, it wouldn't be on this page because that's integration. Inverse.
Inverse trigonometry.
That's inverse hyperbolic functions. Yeah, but no, that's not what we're doing. Just straight inverse functions. But yeah, there's only probably one question, maybe two at the max on the AP Calc test of inverse functions. So, okay. But the first one, there's a lot of questions on this stuff. So we need to understand how to do implicit differentiation. Okay? So here we go. Implicit differentiation, we're going to be doing the rest of the year. Here and there, scattered out throughout the rest of the year. So we need to know. So when there's an x and a y, okay, so two different variables involved, okay, when there is an x and a y, when we take the derivative, we're taking the derivative with respect to one of those variables. Most of the time, we take the derivative with respect to x. So that's why this is d dx. That means taking the derivative with the respect of x. So in terms of x, okay? So we're going to take the x derivative of everything. Okay, so we take the derivative of x squared and the derivative of y squared and the derivative of 1. Well, the derivative of 1 is 0. We know that. Well, the derivative of x squared is just 2x. We know that. The derivative of y squared is 2y dy dx. That dy dx is really, really, really important. So when you take a derivative of a variable that's not that variable, you have to put d, whatever that variable is, dx, or with respect of what you're taking. Okay? So the first derivative of x squared is 2x. The first derivative of y squared is 2y dy dx. Now we're going to get dy dx alone. So we subtract 2x from each side and divide each side by 2y, and we get negative x over y. So the derivative of y with respect to x is negative x over y. That will be the slope of the function. I'm sorry, that does not make sense, but that is how we do it. And do you know what kind of a function this is? Do you know what shape this makes? A circle. Way to go. With the center at 0, 0, and a radius of 1. Now look how this works. Now some of you couldn't give 2 cents towards caring about this, but this is kind of cool. Okay, this is a point 1, 0, 0, 1, negative 1, 0, 0, negative 1. Okay, so no matter where we're at, our slope is going to be negative x over y. So right here, what's our slope going to be? What's our slope of the tangent to this function? 0, right? Negative x over y, 0 over 1. What's the slope of a vertical line? What's the slope of a vertical line? What's the slope of a vertical line? Come on, people. Undefined. Thank you very much. If you put negative 1 over 0, it's undefined, right? So here, the tangent line is undefined. Right here. It would hit this circle, if you remember your unit circle, at square root of 2 over 2, square root of 2 over 2. Okay? What's the slope of that? Or negative square root of 2 over 2, square root of 2 over 2. That is the negative of negative 1. The negative of negative 1 is 1. Slope of 1. See how that works? Pretty cool. So no matter where we're at on the circle, this will give you the slope. Okay? That's implicit differentiation. That's taking derivatives with two variables involved. Okay? Super important to know how to do this. Okay. Which of these four is the answer? I don't know either. We got to work out the problem. You can't just guess on this stuff. Okay? I've had people that go through this as many times as possible and guess until they finally get it right. Not the way to learn this. Okay? So what's the first derivative of y squared? 2y dy dx. Minus, what's the derivative of this? Well, this is all of a sudden the product rule. I have a negative x squared times a y. So it's minus x squared. The first derivative of y is dy dx. Plus y times the first derivative of negative x squared, which is negative 2x. Plus 9x squared equals, what's the first derivative of 4? 0. Okay. If we can get this far, the rest is just algebra. Okay, the rest is easy. It's just understanding where these dyx's come from and understanding that this won't have a dy dx. Why doesn't this one have a dy dx? We did the product rule, but we didn't take a derivative of a y. Here we took a derivative of a y, so we need a dy dx. Here we took the derivative of the x part, so we don't need a dy dx. Okay, so now what we need to do is get dy dx alone on one side of the equation. So what I'm going to do is I'm going to take this stuff and kind of put it together. So I'm going to factor out the dy dx out of just those two things. I get 2y minus x squared. I'm going to move these two things to the other side of the equation. So what are they going to end up as? Well, a negative 2xy moved to the other side is 2xy minus, and then 9x squared. Now we'll divide by 2y minus x squared. So is that over there? It's right here. Okay. Implicit differentiation. Hugely important in AP Calc. You'll never pass the AP Calc test if you don't understand implicit differentiation. Okay? We'll see it a lot. What is the value of dy dx at 0.10? What are they asking for here? What is the root of what they're asking for? Slope. What's the slope at 1, 0? How do you find it when there's x's and y's involved? Well, you do implicit differentiation. Hey, it looks like the product rule again. So let's do it. 2x plus negative 3y times, what's the first derivative of y? Nope, negative 3x. What's the first derivative of y? Dy dx. Plus y times the first derivative of negative 3x. Negative 3. Plus 2y dy dx equals 0.
Okay, so you have negative 3x and then you have dy dx. That's the first derivative of y.
First derivative of y, because the first derivative of y to the first power is 1 y to the 0. Y to 0 is 1. So 1 times 1 is 1 times dy dx. All right. So then we'll get our dy dx's together, the other stuff to the other side. So negative 3x dy dx plus 2y dy dx equals 3y minus 2x. So dy dx times 2y minus 3x equals 3y minus 2x. So if we divide by 2y minus 3x, so you just solve for dy dx. Then you put 1, 0 in. 1 in for your x's, 0 in for your y's. So it's y minus 2, or 0 minus 2, which is negative 2, over 0 minus 3, which is negative 3, which gives us a slope of 2/3. So the slope at 1, 0 will be 2/3 on that function. We good? Same problem. Now we just don't have multiple choice. Okay? Same type of problem, I should say. So what's the first derivative of this? Well, what's the first derivative of x? 1. What's first derivative of y? What's first derivative of y? Dy dx plus y times, what's the first derivative of 2x? 2 minus first derivative of 2y squared. First derivative of 2y squared. 2y dy dx. And the first derivative of 2 is 0. All right. So 2x dy dx minus 2y dy dx. Whoops. Equals negative 1 minus 2y. So if we get these in their own quantity, so dy dx equals 1 minus 2y over 2x minus 2y. And then you fill in the numbers. Oh, negative 1 minus 2y. Then you fill in the numbers. So it's negative 1 minus 2 times 4 over 2 times 2 minus 2 times 4. So it's negative 9 over 4 minus 8. So it's negative 9 over negative 4, which is positive 9/4. That's the slope at the point 2, 4. Okay? So that's implicit differentiation. We'll do that a lot. You'll get pretty good at this. Okay? When we do related rates, that's all about implicit differentiation. Inverse functions. You can write this one on your packet somewhere so you remember it. The first derivative of an inverse function equals 1 over the first derivative of the original of the function. All right. Inverse functions. If h of 2 equals 5, then its inverse is g of 5 equals 2. If these two are inverse functions, then you just flip around the x's and the y's. Inverse functions, okay? Because you switch the x and the y around. So g of 5 must equal 2 if h of 2 equals 5. Okay? Then going by our formula, the first derivative of g, which is the inverse of x at 5, equals 1 over the first derivative of f of the g function. Well, the g of 5 equals 2. So it's the first derivative of f at 2. Okay? So then it's 1 over, what is the first derivative of this? Oh, I'm using f's where it should be an h. This should be an h here. Okay, what's the first derivative of the h function? 3/4 x to the second plus 2. So it equals 1 over 3/4 times 2 squared plus 2, which equals 2 squared is 4. 3/4 of 4 is 3, so it's 1 over 3 plus 2, which is 1/5. Okay?
What does the 2 have to do with the h?
If h of 2 equals 5, then we know g of 5 equals 2. That because we need to know, because it wants the first derivative of 5. Well, the first derivative of 5, we have to put what this is equal to in this.
And then once it's in the formula, like how does that take us back to h of x? That's how I'm confused.
Because you have to take the first derivative of that. So it doesn't ever take us back to here, but we take the first derivative of that and put it down here to solve for it. It's, yeah, this inverse stuff, we don't mess with it very much. It's just now, and then we'll see a couple questions when we review them for the test. So it's not super important, not like implicit where we're going to use it the rest of the year. Okay. So, inverse functions on a table. The following table lists a few values of the inverse functions. So we know that if we're finding the first derivative of g at 2, then this must be an f function. So, and let me go back to the formula. So g prime of 2 is 1 over the first derivative of f at g of x. Well, g of x is, so if we're finding g of 2 equals 9, right? So we're finding the first 1 over the first derivative of f at 9. What's the first derivative of f at 9? Well, it's 1/12. So it's 1 over 1/12. And 1 divided by 1/12 is 12. So when it's h and g, we'd go 1 over g prime of h of 3. So it's g prime of h of 3 is this line, which is 4. So we're finding 1 over g prime of 4. G prime of 4 is 1/2. So it's 1 over 1/2, which is 2. So it's just following the formula and working your way through that. So f prime of 10, so it's 1 over h prime of f of 10. Well, we know if h of -1 equals 10, f of 10 equals -1. Because if they're inverses of each other, this flips around for the other one. Okay? They flip because inverses flip the x and the y. So it's 1 over the first derivative of h at -1, because f of 10 is -1. And then what's the first derivative of h? Well, it's -1 minus 10x to the fourth. So it's 1 over -1 minus 10 times -1 to the fourth. -1 to the fourth is 1. 1 minus 10, -1 minus 10 is -1/11. Inverse functions. Just kind of work your way through the formula. Are we all right with that? Okay, so that's what today is. And then Friday, this chapter is super short. This is the shortest one that we have. We did the first two the first day, these two today, those two on Friday, and then we'll be taking a test next week already over Unit 3. Next week? What's that? Okay. Okay. Boom.